Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Visible Arrows and it's by MD88 Keys. And so that's Dr. Piano, I guess, because 88 Keys references pianos and MD is usually for medical doctor, but I don't know if that's the actual meaning behind it. Anyways, here are the rules. Normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 without repeats in any row, column, or box. We also have counting circles, where a digit in a circle indicates the number of circles which contain that digit. So, for example, if you were to have a 3 here, you would know that there are, in total, 3 circles which contain a 3. And that has some implications related to it, but we won't get into that because that's the solving part of the things. We also have arrows, where a digit in a circle also equals the sum of the digits on the attached arrow, and digits may repeat on an arrow. So, for example, you could have something like 1, 3, and 1 here, and this would add up to 5. And that works because the 5 is equal to the sum of the digits on the arrow, which is 1, 3, and 1. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, first things first, how many circles do we have? So these are counting circles. This is actually a decently common rule set in variant Sudoku. Some people have a problem with it. I don't actually usually have a problem with it, particularly because if you think about it, it's kind of similar to like other restraints where you add up numbers. So in particular, I'm thinking of like cages. If you have cages, you cannot have you have to have unique digits that add up to a certain sum. And it's the same thing with counting circles, right? Because if you have 1 as a digit there, you have 1 digit in a circle. If you have a 2 there, it's 2 digits, 2 circles containing a 2, etc., etc. So if you think about it, it's essentially the similar as a cage, where you have to have unique digits and they must sum up to a sum. And you just count the number, for me, I just count the number of counting circles in a puzzle. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 circles, which means the sum of the digits in them must add up to 15. And we know there's at least 3 unique ones because there are 3 digits in a row here. So therefore, there must be at least 3 unique digits. It could be up to 4 or 5, technically. But if we take a look at this, we have this circle must add up to the sum of these 3 digits, which must be unique. So that's at least 6, and then plus another additional 1 and another additional 1. So that means this digit is 8 or 9 specifically, because you have a sum of 6 plus 1 at least. So that adds up to 8, and therefore this is 8 or 9. So in this digit, we have an 8 or a 9. You could still have 3, you have to have at least 3 unique digits in the counting circles. You could have 4, though. Like, you could be 1, 2, 3, 9, or 1, 2, 4, 8. You could also have something along the lines of 159 or 249 or 348 is a possibility. We don't know though. This unique digit adds up to 3 is 3 digits at least, right? So this cell must be the sum. Oh, also for the if this is 8 or 9, it must be either in almost every row, so at least one row, at least every row and at least every column, except for 1. Um, Or, yeah. So, what does that mean? Well, it has to be one of these two, maybe. This cell, okay. So let's continue with this. This is 3 digits adding up to some digit here. It's 6, 7, 8, or 9, right? This is also 6, 7, 8, or 9 because it's 3 unique digits adding up to another digit. Do we have anything else? No. So the question is, can you actually have first of all, can you have 3 digits with one of them being a 1? Maybe. Because the thing is, if this cannot be 7. So we should actually know this cannot be 7, right? Because if it's a 7 here, that plus 8 is already 15, and we can only add up to 15, but we have 3 unique digits at least. So we would have to have 1, 7, and 8 if that's the case. This could still be 6 if this is 8, right? That would require a 1 to be with the circles, right? Um, hmm. This is at least 1, 2, 3, and 4. So it has a 1, 2 pair here. Because it must be at least 1, 2. It's at least 1, 2, 3, and it's at most 1, 2, 4. This is 1 or 2 here. This is 1 or 2 here. What are the digits on this arrow then? It cannot be 3 and 4. It has to be 3 and 5 or 3 and 6. Or it could be 4 and 5, right? So this is at least 3 and 5, which means this is 8 or 9 here. So this is the same digit as this one, because you cannot have both 8 and 9 in those cells. In addition, if this were 3 and 5 to add up to 8, this would have to be 1, 2, and 4, and therefore this would be 9, which is not allowed, because then we would have 8 and 9 both in the counting circles, and we would have 17 digits in the counting circles, which we only have 15. So this cannot be 3 and 5. It has to be adding up to 9. So these are 9. We know both of these are 9 then. We need a 9 in 9 circles. Well, a 9, that means each 9 has to be unique. Because of that, we know this is a 9, and this has to be a 9, because those are the only circles in their box, and the 9 can only be once in each box, right? So this can't be 9, this has to be a 9, because again, a 9 has to be in every row, and every column, and every box. This is the only 9 in this box here, so this must be 9, which means this can't be 9. In this box, it has to be that 9. This 9 eliminates that 9. In row 2, we know this has to be a 9. In column 4 and row 3 and box 2, it has to be 9 here. So we know we have a 9 here. This is then 3, 6, or 4, 5 here. This cannot be 1 or 2. So if you have 4 unique digits, it's 1, 2, 3, and 9. But I think there's more. Okay, so this cannot be 3. And in fact, so it can't be 1, it can't be 2, it can't be 3. So that means there's only 2 other unique digits here, because we can't have 1, 2, or 3 in this circle. So it must be either then 159 or 249. Well, I don't think it could be 1. It can't be, sorry, it can't be 249. 249 in a circle requires that 2 to be the sum of 2 digits adding to 1, and we don't have an example of that, or just 1 digit adding up to 1. So this must be a 1-5 pair then. So this is 1 and 5, this is 1 or 5. This then cannot be, there cannot be any more 1s in the circles. So this must be a 5, which makes this a 1. Therefore, this is 1. This is 5. This is 5. This has to be a 5 then. This is a 5, and this is a 5. Well, this 9 adds up. It cannot have a 1, so it must be 2, 3, and 4 here. This 5 is either 1, 4, or 2, 3 added together. Same here. This is 1, 4, or 2, 3 added together. Same here. This is 1, 4, or 2, 3, but it cannot be 1 or 2 here, so this must be a 3 or 4, which makes that a 1 or 2. We have a 1, 2, 3, 4 quintuplet, or quadruplet, sorry, in row 7, which eliminates 1, 2, 3, 4 in the rest of the row. This then must be 6, 7, or 8. This is 6, 7, or 8, and this is 6, 7, or 8. This 5 has to be either 1, 2, or 1, 3 here. And this is 1 or 2 here. We know there's a 1 in one of these cells, though, because it's either 1, 2 with a 2. So the 2 can never be here. So this is 1, 2. Or it's 1, 3 with a 1. And 3 then can never be here, right? Because either if it's 1, 2, this has to be 2 to add up to 5. Therefore, this can't be 2. That would be 2. That would be 1. If this is 1, 3, this would be 1, which would eliminate 1 there. So that would be 3, and that would be 1. This 9, it cannot contain a 5. So it cannot be 1, 3, 5. But it can't be 1, 2, 6 because of the 1, 2 possibility cell in that box. So this has to be then 2, 3, and 4, which makes this 1. Therefore, that's a 1. This can't be a 1 here. Where is the 1 in row 5? It cannot be any of these cells because of the 1s in the box. It must be here. So this must be a 1, 4 pair, which eliminates 1 and 4 in the rest of the row. We then have a 6, 7, 8 triplet in the rest of the row because we have a 2, 3, 2, 3 pair here. In this box here, one of these digits is a 3 or 4. One of these digits is a 3 or 4, and this can't be 5 actually. So that means in this box, we cannot have a 1, 2, because one of these cells must be a 1 or 2, and we can't have a 3, 4. So the rest of the box must contain 5, 6, 7, or 8. But this can't be 5, this can't be 5, and this can't be 5 because of the 5s in the column and the 5s in the box. Therefore, this must be a 5. This adds up with 9 to add up to, sorry, this adds up with another digit to add up to 9. So this must be 4, which means this cannot be 4 here. Therefore, this is a 1, 2, 3 triplet here, plus 1, and then it must be 2 added to it to add up to 9. So this is 2, whoops. This is 2, which makes this not 2 and 3, it's 1 and 4. This can't be 4 because of the 4 in the row, so this is 1, this is 4. This 3 cannot be there because of the 1, 2, 3 triplet in the row. So this must be 4, which makes that a 1. One of these digits is 2 or 3, right? Because we cannot have a 2 or 3 in the rest of column 4. So it's either 2, 7, or 3, 6 here. We have a 1, 2, 3, 4. Actually, we have a 1, 2, 3 triplet in column 6, which eliminates 1, 2, and 3 in the rest of the column. Therefore, this can't be 2 or 3. This is a 4, which means this can't be 4. Where is the 4 in this box? It has to be here. because of the 2, 3, 4 triplet. This can't be 4 here. So we also have a 1, 2, 3 triplet here, so that means the rest of the digits are 6, 7, and 8. This is also 6, 7, or 8. These two digits must add up to 9, and 1, 8, and 4, 5 are eliminated because we already have a 1 and a 4, 5 in that box. Therefore, this is also 2, 7, or 3, 6 here. These two digits must add up to 9. It cannot be 1, 8. It could be 2, 7, 3, 6, or 4 and 5. Same with this. This one cannot be 1, 8 because of the 1s already in the rows. So this is 2, 7, 3, 6. And it cannot be 4, 5 because 5 is eliminated in both of those possibilities. Okay. Where are the 1s? Okay. This can't be 4 because of this 4. Therefore, this is a 1, which makes that a 4. This 1 means this can't be 1, so this is 2, which makes this a 1, which makes this a 2, to add up to 5. This then cannot be 2 and 7. It's a 3, 6 pair, which eliminates 3 and 6 from the rest of the column. Therefore, this can't be 6, this can't be 6, and this can't be 3. That makes that a 2. None of these can be 2. This can't be 2. That's a 3, which makes that a 2. This 3 eliminates that 3, so that's a 1, which makes that a 3. We have 8 1s now. We know where the last one has to be. It has to be here. We know where the 2 is in row 3. It cannot be any of these anymore, so this is no longer 2, 7 possible. Actually, 7 could be here still. This can't be 7 here, though. Okay, 2 in row 3 cannot be any of these cells because the 2's in the boxes, so it must be here. So this is 2. 2 cannot be here, here, or here in this box in the lower left. So it has to be along the arrow, which means it's 2 and 7 adding up to 9. This can't be 7. This can't be 7 then because of those. These two digits add up to 9, and it cannot be 1, 8, 2, 7, or 4, 5. It's 3 and 6 here. Well, because we have a 3, 6 pair here, we also have a 3, 6 pair here, that means 3 and 6 cannot be in the rest of row 1 or the rest of row 2. So this cannot be 3 or 6. This must be a 5, which makes that 4 to add up to 9. This can't be 6 because of the 3, 6 pair in the box. We also know where 4 has to be in this box in the upper center. Can't be here, can't be along the arrow, can't be the filled in digits, it must be here. Which leaves a 4 in the upper left corner in this cell. Actually, that was the 8th 4, so we know where the 9th one had to be. It had to be here. We have 7, 8 remaining in this box. 3 and 6 have to be the remaining digits here because they can't be in the rest of row 1s and 2. So this is 3 and 6, which means this is 3 or 6 to add up to 9. This is 3 or 6. This is 7 or 8. Remaining digits in this box here in the upper right is 7 and 8. So it's 7, 8, 7, 8. This 3 means this can't be a 3, so this is 2, which makes that a 3, which makes that a 6, which makes that a 3. That eliminates that 3, so that's a 6, that's a 3. That's 3 in the corner. We celebrate because we know we're getting close to solving it. This can't be 6. This 2 means this can't be 2, so this is 7, which makes that a 2. We have 8 2s. We know where the last 2 has to be. It has to be here. I think we have a decent amount of 3s. Well, we know where the 3 is in the lower left. It can't be here, can't be here, and can't be here. It must be here. Therefore, we know where the 3 is in the lower right. Can't be here, can't be here. It must be here. we know where the 3 is in, well, this 3 means this can't be 3, so this is 6, which makes that 3. We now have 8 3s, where we know where the last 3 has to be. It has to be here. Okay, do we have all the 4s? We do have all the 4s. Do we have all the 5s? We don't. We know where we have 8 5s though. We know where the last one has to be. It has to be here. 6s are kind of limited right now. 7s and 8s also. 9s we already finished. This 7 means this can't be 7, so this is 8, which makes that a 7, which makes that an 8, which makes that a 7. This can't be 7 then. Where is the 7 in row 7? It can only be here now. So this is 7. This is 6 or 8. The remaining digit in column 7 is 6, so that's a 6. It's a 7-8 pair here. This can't be 6. Therefore, we have a 7-8 pair in the central box, which eliminates 7 and 8 in the rest of the box. So this is 6. Same here. We have a 7-8 pair in row 5. That makes this a 6. This can't be 6 anymore, and the only possibilities are 6 and 8 for that cell. So this is 8, which makes that a 6. Which makes that an 8, which makes that a 6. This 8 means this can't be an 8, so this is a 6. This 8 means this can't be an 8, so it's 7. This is 8. This is 7. This is 8. This is 7. This is 8. This 7 makes that an 8, which makes that a 7. This 8 makes that a 7, and therefore this is an 8. And that's how you solve it. Yeah, it's a nice combination of counting circles and arrows. I hope it made sense, the reasoning of how I came with the counting circles. Yeah, it was really particularly this arrow, which allowed us to know that everything had to be 9. And therefore, since there are only 9 9s in the puzzle entirely, every 9 must be in a circle then. So, and then from this, we knew 2 couldn't be in any of the circles. Actually, we knew this clue, we knew this would have to be 1 or 2, so it could not be 3. And it couldn't obviously be 1 or 2 because 2 unique digits can never add up to 1 or 2. So this had to be greater than 3. So we knew that from this, there was only 3 unique digits because it couldn't be 1, 2, 3, 9. And from there, there was only one possibility for 1 or 2 to be in a circle. And therefore, it had to be 1. And it was 1, 5. Anyways, I hope that you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.